Okay, let's take a look the first example, or the example one. We have y prime minus 4x y equals 3x inverse y inverse. Try to finish these problems for me. This is a Bernoulli equation, right? I'm gonna write down the Bernoulli equation here. We have and that's a type of Bernoulli equation, and you need to be careful if for n, for this case, n equals -1, right? N equals -1. Let's just try it. One more minute. Okay, I'm gonna write down the answer on board. Let's take a look. So for this case, it's very clearly we can see n equals -1. So u equals what? Y to the power 1 minus n. Right? And we can see this guy, we can write down the y equals what? Y equals right? Y equals u to the power 1/2. And of course, we can write down the dy over dx, use the power rule. Right? And then we can plug in these two. Okay, we plug in these two. What dy over dx is gonna be 4x. Here's y equals u 1/2. And the 1 over y is u. Right? Now we're gonna remove this term, right? Remove this term because we want to transform this guy to the standard form. Then we can use the formula, right? So this guy, we're gonna times 2u to the power 1/2. We times this guy for both sides. We can simplify it. 2 times 4, 8x. U. This is 6. We can write down x inverse like that. So we transform this guy to the standard form. Then we can use what? We can use the formula we learned before, right? So for this guy, we basically use c e to the power px dx. E px dx. E px dx. Fx dx, right? That's the formula we learned before, right? Formula. I want you guys memorize it, okay? Memorize it. So px for this standard form, px is this guy. Fx is what? Is this guy, right? Okay. And then what are you gonna do? We do the integral, okay? So integral of this guy will be right? Like that. Now we're gonna plug into the formula. fx dx. Okay. We have e ln x to the power 8, e ln x to the power 8. And this guy x to the power -8. Okay. Now what are we going to see? Here is cx to the power 8, x to the power 8 times, here's x to the power, and this one can write out like that, right? Basically, we're going to do the integral of this guy. Integral of this guy. And it will boil down to the like that. Use the power rule, right? Power rule. So we're gonna get Qifang, do you have a black pen? Black ink pen? It doesn't work so well. I need, you don't have a blue one? Okay. -8 x to the power -8. Okay. And again, this guy is a -8. We have cx to the power 8. Here is here is x to the power 8, negative power 8, 0. Here x divided by 8 going to be 3/4. Okay. And as we know, u equals what? U equals y squared. Right? So we can plug in. And of course, you can get the solution like that. You can write the answer like that, or you can write down the answer could be like that. Okay. The answer like that. Now, I have a very special case. How about this guy, for example, when I change this guy to initial value problems, okay, I add a very special initial condition. So when x equals 0, y equals 1. Okay. When x equals 0, y equals 1. What does that mean? That means when x here equals 0, y equals 1. Okay. So we plug in into here. Okay. We need to plug in here. Okay. Plug in here. So when x equals 0, gonna be 0 to the power. Oh, sorry. When x equals 1. When x equals 1, y equals 0. Right. So I make a mistake. Here's a 1. Okay. Y equals 0. Okay, and then what are we going to get? We can get C equals 3 over 4. 3 over 4. Okay, and then the solution going to be oh, it doesn't work. I need to find a pen. Guys, could you wait 1 minute for me? I need to find the pen. Sorry about that. You don't have any blue pen? You just have a pencil. Okay. Okay, let's continue. Sorry about that. So here the solution should be is the solution of IVP. Okay, so that's the solution. Okay. Now, today we're gonna learn something different. Okay, something different. We're gonna learn the mathematical model for the application. Okay, for the application. So the first model we call the linear models. For 2.7 linear model. Linear models. I will call the growth and decay. Okay. So the first things we need to address the IVP problems. dx over dt equals kx. Okay, so basically we want to just this guy, and we call this is a growth and a decay model. Let's take a look. The coefficient k. For the k greater than 0, it is growth model or growth constant. Okay, opposite. K less than 0, that means it is decay constant. Okay, decay constant. So that's the coefficient k. Now, I'm gonna give you guys an example how to solve this guy. A culture initially, let's take a look at this example. Initially has P0, number of bacteria. At T equals 1 hour, the number of bacteria is measured to be 3/2 P0. Okay. If the rate of growth is proportional to the number of bacteria PT present at time T. Determine the time necessary for the number of bacteria to triple. Okay, so basically what we're gonna see is it's very clear that is about growth and decay. For this case, is growth is very clearly is a growth model, because bacteria are always increasing, right? So it's growth model, and we can use this model to mimic this bacteria growth. Okay, so we can build the model like that because the independent variable is PT. So we can write that as like that, dP and kP. Okay. Previously we used the X independent variable. Now I use the P, right? Here's the P. Okay, we also have initial condition. Because initially is P0. So very good. We have when T equals 0, that is P0. Okay. And at T equals 1 hour, the the number of bacteria is measured to be 3 over 2 P0. So we have another condition that is 3 over 2 P0. When T equals 1, and the number of bacteria is measured to be 3 over 2 P0. Okay, so basically we build this mathematical model and we wanted to solve it. Okay, so let's take a look how to solve this guy. The first things you need to solve the ODE, right? After you solve the ODEs, then you plug in the these two. Actually, that's two. These two initial conditions. Oh, not initial conditions. These two conditions. One is the initial condition. One is another specified condition. Then we find the coefficient K and C. Okay, K and C. Now let's take a look. So we have what? We have solved this guy. As we can see here, K is a constant. To treat K as a constant. And do you guys have any idea how to solve this ODE? Any idea? What kind of method we can use? We learned that before. We can use separable method, okay? Because here it can be written Fp times Ft. T is 1, right? So we can use separable method. We put the P in the on the left-hand side, the T on the right-hand side. Right? Then do the integral for both sides. And again, we're gonna get limit okay. Okay, after you get this integral, you can write down P is equal to what? Is positive negative KT plus C1. All right, and you can also write down as like that. Okay, and this, the whole thing can be recognized as another C because this term is a constant. So P equal to E to the power KT. Okay, that guy is the solution of ODE. We got it, right? Now I want you guys to find the coefficient C and K by using these two conditions. We have two unknowns, two conditions. Definitely we're gonna solve it, C and K. For this case, T equals 0 equals P0, okay? T equals 0, P equals P0. And another case, T equals 1, P equals 3 over 2 P0, okay? Plug in these two conditions here to find the coefficient C and K. Try it by yourself. Chifan, did you get it? Okay, now I'm gonna show you guys the answer on board. You guys need to be very familiar with this kind of linear equation systems. If you take the linear algebra, you're supposed to know how to solve the equations with two unknowns. Two equations, two unknowns, how to solve it, okay? So let's take a look at the first condition. That is P0 equals P equals 0, P equals P sub 0, right? So we have the model here, we have the solution here. So we'll just plug in this the first condition. CE k times 0 equals P0. Okay. And that's the first condition. Second condition, when t equals 1, p equals 3 over 2 P0, right? So times 1 and okay. Now from the equation 1, we can say e to the power 0 is 1. So we can say c equals P0. Okay, from equation 1. And for the equation 2, we can write down it like that. C E K equals 3 over 2 P0, right? And it's very clearly we can say C equals P0, plug in, right? And then e to the power k. And how to solve this case? Any idea? Do the ln for both sides, right? And do the ln, k can be outside, ln e gonna equals 1, right? So k equals 3 over 2. So that is a logarithmic function. I wish you guys learn it from your college algebra or whatever. Did you learn it before? Chico? You can forget it. Okay. So k equals ln 3 over 2. Ln e, you can put a k outside. Okay. K outside ln e equals 1. So okay, that's the things you're supposed to learn from your college algebra or something like that, or your calculus at least. Okay. Ln e equals 1. Okay. That's the definition. Okay, so we solve the C and K with P equals P0 times T, okay? So that's the solution. That is the solution, okay? And also, now we have the last problems. If the rate of growth is proportional number of minutes per minute, then determine the time necessary for the number of bacteria to triple. Okay, to the triple, that means 3 times of the original one. The original one is P0, right? So if we want to get the triple, we can plug in. So now it's a triple That means 3p0 equals p0 2, right? T. And we're gonna solve it. T equals cancel. Okay. Now you can use your calculator. You got this guy is roughly equals to 2.71 hour. H means hour. Okay. It will take 3 hours. The number of bacteria we're gonna go to triple. Okay. It will take almost 3 hours. The bacteria gonna go to triple. So you can tell the growth of the bacteria is so significantly. Within just 3 hours, it's gonna go to a triple, right? So from the model, we can tell how the bacteria grows. Okay, that's a good thing. So far, any questions? No question. We're gonna go to another one. Okay. Okay, I want to mention again, that's the solution for this guy. And that's the second solution for the second problem. Okay, the second problem. Okay, so now I've got another terminology we call half-life. A half-life is simply the time it takes for one half of the atoms in an initial amount A0 to disintegrate or transmute into the atoms of another element. So let's take a look. Half-life. What does that mean? Half-life. I'm gonna draw a picture. So we assume the amount of atoms. You guys probably learned the atoms from your physics or chemistry. Okay, atom. We have such amount of atoms, and then after some time, it becomes one half. Okay, so this atom transmute or disintegrate to another atoms. Okay, to another atoms, and so the original atoms becomes one half. Okay, becomes one half, and this time we called the half-life. Okay, So from A0 to A0/2 or half A0, this time we called half-life. Okay, half-life. That's the definition. Now let's take a look at an example. That's a little bit technical. A breeder reactor converts relatively stable uranium into the isotope plutonium after 15 years. It is determined that 0.3 of the initial of them is disintegrated of the initial amount A0 of the plutonium has disintegrated. Find the half-life of this isotope if the rate of disintegration is proportional to the amount remaining. Okay, so let's take a look. We assume this guy, this guy, all the plutonium, let me say, we assume AT is the amount of plutonium remaining. Okay, amount of plutonium remaining. Okay, we assume AT is the amount of plutonium remaining. Okay, so we can see AT, and we can build the mathematical model for this guy because it's a decreasing, right? AT is decreasing. Now we can use the model we learned before because that is a decreasing model. Let's take a look at the model we learned before. If you can use this model, now it's a decreasing of the A. We use this model, take a look. So if we assume this guy, we have the A over dt equals K times A, right? Just change the A to X to A. Now we're gonna check the initial condition. We know A0 will equals A sub 0, right? The initial amount here, right? The initial amount here is A0, like we did before, right? Initial condition. And here we have another condition. That is this guy. After 15 years, it is determined that 0.043% of the initial amount of A0 has disintegrated. So how to build the condition for this guy? That means what? After 15 years, t equals 15. And how to build this condition? It should be the remaining gonna be 1 minus 0.00043. And be careful, it's this guy. Okay, you need to be careful. Here is only about 0.043% of A0 disintegrated. Okay, so what's the remaining? It's 1 minus this guy. 1 minus 0.43%. Change the percent to here, we add 2 more decimal, 0.043. So the remaining gonna be this guy, okay? I'm pretty sure some of you probably will make mistake. Just write down as 0.0043 is 0. It's wrong, okay? That's the part disintegrated, okay? Disintegrated. Now we want to check the remaining. That means 1 minus this part, okay? You need to be careful. Okay, after you build this model, then everything should be very straightforward. The first thing, so you're gonna solve this guy, right? You're gonna solve this guy. To solve this guy is a very similar to solve this guy, right? Solve this guy. And we know solve this ODE, we're gonna get this one, right? We gotta get this one. And the same things, I save the steps. Follow the same strategy, you're gonna get A equal to C e to the power kt. And that is the solution of ODE, right? We can solve this guy, use a separable method to solve this guy. We're gonna get a very similar result like P, okay? Like P. We just copy it. Now, I want you guys try it, these two conditions, and solve the C and the K. Do it by yourself, okay? I want you guys keep practicing so you can know how to use a logarithmic function. Did you get your K and C? We have two conditions, right? To solve these two conditions. And it's very similar to the previous example. Plug in these two conditions and find the C and the K. Sure, it's too hard. And you can use your calculator if you want. Okay, I'm gonna write down the answer on board. So basically, you plug in these two conditions. When when t equals 0, and we got initial condition is a sub 0, right? And another one is when t equals 15, and we're gonna get the initial condition is this guy, right? So what are we gonna do? From the first condition, from 1, we can see c equals a0, okay? And from 2, a0 plugging c is a0, we get it. And this part you can use your calculator. That is 0.9995780. Okay, and we can cancel out a0. Sorry, this is k. I forget the k. We can get 15k equals 0.9957. Right? And we can do the length. We put the length for both sides. 0.9957, and we can see the k equals some of you may use the calculator. You can calculate this guy directly. It's 0.00002867. K is less than 0. It's right because it's a decay province, right? It's a decay province. It's not a growth province. So here we got negative. That means our model is right. Our model is right. And you can plug it back. We're gonna get a equals c plugging in is a0 e to the power okay, and we have here's a t, right? Here's a t. We plug in these two coefficients back to here. One is c, one is k, right? So we got this model. Very good. Now let's take a look at the question. Find the half-life of the isotope if the rate of disintegration is proportional to the amount remaining. Okay, so half-life means that guy disintegrate to 50% of the initial one, or half of them, right? So we just need to write down the half of them. Right? And solve the t. We cancel out the a0. So we can have, basically we're gonna get have 0.5, right? 0.5. And we do the lamp for both sides. And t equals what? T equals ln 0.5 divided by, if you calculate the ln, 0.5 will give you the negative number. Use your calculator, okay? Give you a negative number, and this guy will give you roughly 2 for 180 years. Okay. That's the way we calculate the half-life. Okay, half-life, yes.